Hey, what's going on, everybody? These are the video notes for section 7.2b, dividing polynomials. Now, I'm actually going to kind of break out of this to show you something. So I'm actually technically skipping a section of notes on the videos here. Sorry, kind of discard this here. So I'm actually skipping another section here. It says actually 7.2, this would be A, and it's basically just dividing polynomials using long division. This first section here, so again, you're going to notice that I'm skipping this in your notes. This is honestly, for what we're going to be doing in class, it's honestly not that useful, or it's really not that important to know. It's just kind of a stepping stone from using this to what we're about to do here. So again, this 7.2a, this is the long division part in your notes. If you want to pause, write the stuff down real quick, you can, but I'm not going to spend very much time on it. I'm going to go right into 7.5 which is going to be synthetic division. All right, now this is really the division that we're going to be using mostly when we're trying to solve these polynomials out. So again, synthetic division of polynomials, so it's essentially just a way of dividing polynomials. If one of your divisors, essentially the smaller polynomial, is a binomial with a leading coefficient of 1, and the biggest exponent has to be 1. All right, so that's essentially how we use synthetic division, and these are the rules for synthetic division. So not every, not every two polynomials can be divided using synthetic division. All right, and then you have the steps here. I'm going to mostly just demonstrate. If you want to pause the video now and write this stuff down in your notes, you can do that. I'm going to move on to a couple examples here, okay? Now, with synthetic division, now again, I have to look to see if my rules satisfy. X plus 3, do I have a binomial? Yes, I do. 1 and 2 terms, that's a binomial. Is my leading coefficient a 1? Well, if I actually look, there's literally no number out in front there. So yes, the leading coefficient is a 1. And then if I look, is my highest exponent here by my x, is that a 1? And if I look, well, it actually is. So from there, I can now use synthetic division, okay? So again, I have to look so leading coefficient, degree, or exponent, and then binomial. And those are the 3 things I'm looking for, all right? 3 things. Now, the way that we're going to use this, so normally when we're using long division, we'd use a symbol that looks something like that, correct? But now, for synthetic division, what we're going to do is we're going to take essentially that and basically flip it upside down, all right? Now, there's going to be a number out here and then multiple numbers inside here. The number out here is going to be the number inside of our binomial, but opposite of the sign. So if it's a 3 inside, it's going to be opposite the plus, which is going to make it a negative. So it's going to be a -3 outside of our bracket there. And then inside of our bracket here, what we're going to do is we're just going to take the coefficients, the 1, the 6, the 8, and the -2, and we're just going to write them out here, all right? No x's, no exponents, just the numbers. So it's going to be 1, 6, 8, and -2. And when you're writing it out, I would leave a little space kind of down here below these numbers so that when we start synthetically dividing, it just kind of makes it a little bit easier. So from here, what we can do, we're going to take this 1 down here. All right, we're going to take whatever the first term here. It might not be a 1, might be a 3 or 4 or whatever it is. And we're going to take it down here, all right? And what we're going to do is we're going to multiply this -3 to this 1. So -3 times 1 gets you -3. We're going to take that -3 and put it below the next number, so below the 6. And then with these numbers, we're going to add them. So it's going to be 6 plus a -3, which is just 3. And then from there, we just repeat the process. So it's going to be the numbers that are down here, multiply to the numbers that are up here, all right? So it's 3 times -3, that's a -9. And then the numbers that I put above each other right here, those numbers add. So it's 8 plus a -9, which is -1. And then repeat, -3 times -1 is just 3. 3 minus 2 is 1, all right? Is the number 1, all right? So from there, what we do is, once we have the number out here, once we have our final number here, I always put a little bit of a box around it. This number right here is going to tell us if we have a remainder, all right? That number is going to tell us if we have a remainder. If it's a remainder of 0, if 0, then we have no remainder. Have no remainder. Oh, went a little bit too forward there. All right, so again, if that last number is 0, then we don't have a remainder, all right? All right, now writing out our final answer here, all right? These numbers that we got right here that are below the other numbers, those are the coefficients of a new equation, all right? Now, the degree of that equation, or the exponent of that equation, is 1 less than our original equation here, all right? So in the way I kind of write it out, the way that I kind of demonstrated here, so if you had an x cubed right here, so if the power is 3, then the new equation is going to have a power of 2, or the highest power of 2. And what I'm going to do is, in front of my first number, I'm going to write out my highest power, the x2. And then my second number, I'm just going to write x until I run out of x's. All right? Now, these numbers up here, these are the coefficients of these new variables. So 1x squared is just x squared. I don't have to write a coefficient of that. The 3 becomes the coefficient in front of the x, so it becomes x squared plus 3x. I've run out of x's, so the last number here just becomes my new, just becomes a constant, -1. And then because I have a remainder here, what I have to do is I have to take it plus, and then whatever this remainder is, over, this is going to turn into a fraction, over my original divisor, the x plus 3, all right? This is going to become 1 over x plus 3. And that right there is our final answer when dividing out, all right? All right, I'm going to pause the video, erase this, and then we're going to work out this second example here. So if you want to pause, write anything else down, just please do that. All righty, so we have, so we're going to do example 2 here. So we got x to the 4th minus 4x to the squared plus 6, all right? So we'll set up our division bracket here. Number that goes outside is this number here, opposite sign. So if it's -4, it's going to be a +4. Hang on. Stupid thing. So we have the +4 out there. And now we put our coefficients in here. Now, so if we're starting off with an x4 or whatever degree that we're starting off with, when we synthetically divide, every single x has to be accounted for. So when I plug it in here, I have to have the coefficient for x to the 4th, I have to have the coefficient for x cubed, I have to have the coefficient for x squared, and I have to have the coefficient for x. I have to have all of this accounted for in my synthetic division. But if I'm looking here, I don't have an x cubed or an x value here. All I have is x to the 4th and 4x squared. So what I'm going to do is I'm still going to use that coefficient of the x to the 4th, use the 1 there. And for x cubed, I'm going to put a placeholder there. I'm going to put a placeholder of 0 there, all right? And then for the -4x squared, well, the 4 is out front of the x squared. And then the x, there's no x, so I'm going to use a placeholder of 0. And then in front of the 6, I'm going to use the 6 there, all right? Okay? So, all right, so again, these are the placeholders for x cubed and for x. Even though I don't have any of those in there, I still have to have a placeholder for them. And then other than that, the process is still the same. I'm going to bring down this 1 here. And then 1 times 4, that just gets me 4. I add these numbers inside here. 0 plus 4, that gets me 4 again. 4 times 4, that gets me 16. I add these. Negative 4 plus 16 gets me 12. 12 plus 4 is 48. 48 plus 0 is 48. If I multiply those together, I get 192. That's not 129, 192. I add those together, 6, and I get 198. Put a square around that last number. I always recommend putting a square around that last number there. All right. All right. So again, numbers down here, we just multiply. All right. Just multiply to get these numbers up there. Now with this right here, I look at my degree, my highest exponent. Highest exponent here is 4. So I know that when I set up my new equation, I'm going to have a highest exponent of 3. And then from there, I'm just going to fill in x, and then below, so in front of the first number here, I put the x3. And then for the second, x squared, the next x, and then the next is just going to be my constant. So with the new equation, I have x cubed. The coefficient out front is 1, so I have 1x cubed. All right, don't have to write x cubed out anymore. All right. The coefficient of x squared is going to be 4, so it's going to be plus 4x squared. The 12 is going to come down in front of the x. It's going to become plus 12x. Then I don't have any more x's to use, so I'm going to bring the 48 down in front of that. So plus 48. And then I have a remainder here. This is not 0. If there is a remainder here, I have to write out plus, and then whatever this remainder number is, so the remainder number over my original divisor here. So it's going to be over x minus 4. All right. So again, that's synthetic division right there. I'm going to pause the video here real quick. Sorry about that. So if you want to pause this video and kind of rewrite and just write down all this stuff right here, you can go ahead and do that. I'm actually going to transition to another slide. Discard that, and then I'm going to just do another one, and we're going to do another example. All right. Now, technically, this one asks us to use long division. Again, I'm skipping long division for this video series. You can, if you want, you can look up videos, but again, we're not really going to use it. It's just kind of a tool for us. We're just going to use synthetic division because, again, with this one, I have a binomial with a coefficient of 1 out front and an exponent of 1, all right? So literally, it's a binomial that literally looks something like this. No number out front, no exponent by the variable, plus some number. So with that, I'm going to set up my synthetic division. Upside down bracket right here. I have the number out front is this number here opposite the sign. So if it's plus 6, it's going to be a negative 6 out here. And then in here, I'm going to write out all my coefficients. So coefficient of 1 out there. I'm going to start off with 1, then 12, then 36. All right. So, and then it's the same process. Whatever this first number is, I'm going to drag it down. It becomes 1. 1 times negative 6 gets me negative 6 right there. I add these numbers here. 12 plus negative 6 gets me, well, 6. I'm going to multiply these numbers. 6 times negative 6, that gets me negative 36. And then I bring that down, add those together. 36 minus 36 is 0. All right? Now, my highest exponent here. Highest exponent is 2. So when I bring it down here, my highest exponent is going to be an exponent of 1. So I'm going to start off with x to the first power, or just x, all right? And after that, I don't have any more x's to use. So I'm going to bring it down. The 1x, or just x with a coefficient of 1, is just x, all right? And then my 6, there's no more x's to use, so I'm just going to bring that down as x plus 6, all right? Now, with my remainder of 0, that means that now with my final number being 0, that means I don't have a remainder. All right, I have no remainder there, all right? So if I have no remainder, this is my final answer, the x plus 6. I don't have to add anything on to the end, don't have to do anything else, all right? All right, so that's synthetic division, all right? Make sure you are asking questions. If you're missing any days, please make sure you're asking questions. This is an extremely important tool that we're going to be using here over the next few chapters. Thanks for watching. Goodbye.